Hi, this is Karen O'Brien, and we're going to be doing part two of a Levee overview, Levee modeling and mapping methods. And so last week we showed you how to connect to the data from the Army Corps Levee network and how to download and use their data to create your levees. This week, I'm going to kind of talk more about levee mapping, levee results, running models, making sure that they're functioning correctly, and things like that. So we kind of know from our levee, let's just connect to that data again real quick. It shouldn't take very long. So because I put that connection in last week, my computer remembers it. So I can just click connect. And then we'll do alignment lines. And I also want to do levied areas and click add. You can wait for those to load there for a second and then close that. And so you can see, let me turn some of my Flow 2D stuff off real quick. So you can see that our levied areas are here. And let's there we go. I was going to say that I know we got better levied areas than that. Let's give it a chance to load. Now, remember what we've done is we've just connected to the entire country worth of data. So it takes a bit of time to load. So you don't want to be zooming and panning and stuff when you're connected to these levees, but it is going to show you that this is the, 100-year protected areas and and the levee alignment for those protected areas. What I want to do is go to my comp domain. There we go, right here. Because I want to show you that we have this one little area right here that is not levied according to the flood control. No, sorry, not the flood control. According to the Army Corps. And it's probably because this is just a little generic spoils pile that is like adjacent to a ditch. So whatever they pulled out of the ditch became this uncertified or unmappable levee. But the bottom line is that it's still here and it still does function when the river floods. It does something, right? It either contains or it traps the water with this line along this line of demarcation, right? So we want to talk about that today. So let's get rid of these guys because we want to see a couple of things later. We'll just close them for now. So last week I showed you how to um, basically like copy these lines into your levee lines and turn them into levees. But I have refined that process in that video, which again, right here, I refined that process and broke that in that was done in like 2 or 3 steps as I was learning how to do that. And then I put that into a single script that does everything at once. And we're going to test that today. So that's what video number 2 is. It shows you how to do that and how to set up that script and align the data. So what I did last week is I used the alignment line from the Army Corps' website, and they had a bunch of cross sections, and I was trying to use those cross sections to set my levee crest elevation, and that was not really very functional. It was kind of annoying because they just had too many of them. So I changed my methodology up a little bit where I thinking, okay, I don't need a point every, 100 feet or whatever. Why don't we just stretch that out a bit and let's get a point, say, every 500 feet. And so I did a point every 500 feet. And I also asked ChatGPT to build me a script that would put that point every 500 feet along the levee and then buffer around that point to get my high elevation and then assign that elevation to these points right here that are snapped to the line, to the levee line at every 500 feet. So here's that script. And this is the levee crest elevation extractor Python script that uses the layer levee lines and elevation points and this LiDAR data elevation that was converted to feet. Now, the cool thing about this system is that it doesn't care what coordinate system your elevation data is in because it uses a zonal statistics within that polygon. So it doesn't care if you are trying to do something like warping elevation data, then the coordinate systems are important. But if you're doing something like zonal statistics, it doesn't care what the coordinates are on your levee. It's just going to return the maximum of the pixels inside a buffer. And so that's exactly what we're doing. So before we explore this tool again, let's start with something a little different. So that what I did when I ran these levees is I ran them for like different flood events. And I set that up using just a inflow hydrograph at this channel. So we're not really considering any rainfall or anything outside of this. We're really just dealing with the rainfall, or sorry, excuse me, the hydrograph in the channel at this point. And what I've done is I have gone to my boundary condition editor and I have set up a couple of kind of fake hydrographs. They're kind of fake in that they get the peak relatively good, the peak of the 100-year or 10-year or 2-year event. They get the peak pretty good, but they don't probably get the shape very good. So they might have like a little bit too much volume. So this is this fake hydrograph that I made. Um, I could probably go back into old reports and find these hydrographs. I just didn't want to do that. Instead, I'll just use this one that ChatGPT made. So probably a little bit too much volume in here, but the peak is probably pretty accurate. 10-year, you can see the 10-year and the 2-year and a base flow. So the gauges in this area are giving us a summertime base flow of around 200 CFS and like maybe a September base flow of around 600 CFS. So I just put in 1,000 CFS or just about 1,000 CFS because I wanted to make sure that my channel could contain that, and it can. So then I ran my base flow, ran my 2-year, ran my 10-year, ran all these different scenarios and looking at with the idea of understanding how they're going to work with my levees. Okay. So in order to change my run, I just change my inflow hydrograph, schematize it, and then export that data set and it'll start running with a quick run. Change that to the next flow, schematize it, and then start the next quick run. And you can just do that in series. This model runs really quickly, of course, because it's a training model, so it runs really fast. So you can see that it runs in, oh yeah, just a few minutes. Or maybe like a minute. So it runs super, super fast. Okay. So I have all these different runs to show you. And what I do with these runs is I basically kind of focus on the ones that are important to us, which are like the 10-year and 100-year events. So just for the sake of like simplifying the map so you can see things a little better, I'll turn off these elevations and then we can start looking at some of these results. So once you run a model, you have some options. You can either map some things with Map Crafter, which in this case I would be like looking for my maximum depths, or you can get your channel data, or you can use and this will come in like appropriate colors and it'll be kind of grouped together nicely, but it's a lot. It's kind of annoying. So if you're just doing a lot of different and you just want a single map of different projects, you might not want to use Map Crafter because it's just too much. So instead, I use Rasterizer, which Flow2D Rasterizer, Flow2D Map Crafter. These are both plugins available on QGIS. So you just go to your plugin manager and you search the repository for them and they should come up. So this is Flow2D Rasterizer. And basically you put it to the output file that you want to map. In this case, that would be 100-year. This is the 100-year without the safe storage levee, and it's looking to map depth.out. Depth.out is a combination of the channel depth and the floodplain depth, and it's the maximum. A depth.out file, the reason Rasterizer works with only certain types of data is because it reads the data by columns and it isolates the X and Y and the elevation and it makes a grid with that. So it ignores the grid number, isolates the X, Y, and depth in this case, and maps that for you. And it works really good because it's a very simple plugin and you just can set the name of your raster and everything like that. So if you click run, it will add a map to the map, and then I just group them together down here. So I'll go ahead and cancel that. We don't want to do that again. So what I mapped was um, a couple of different maps. So here's your maximum channel depth. And I wanted to map that just so that my time depth maps didn't look funny. And I also have my 100-year max with safe storage applied up here and the 100-year max with no safe storage applied because this is not a levee that can be, used by your flood mapping because it's not a certified levee or it's not part of the a levee system. So they don't even account for it. But that can be troublesome because if you have a lot of these along the Rio Grande Valley and you're trying to model the whole Rio Grande Valley and you're not accounting for this safe storage, two things might be happening. One is that if this safe storage is not applied, you are having some attenuation happening up here that is not allowing that flood to be pushed and forced downstream. So you have some storage up here. Now, and of course, that's fine, right? That's all fine and dandy until you're talking 250 miles of river, and that's, maybe not appropriately accounting for safe storage. Now, the second issue is if you do get water on the other side of this levee, that's again water that could be stored and trapped over here by the levee. Again, attenuating like what's happening downstream. So either scenario, you don't want to just leave these features out of your flood study. You're going to want to model it with and without. So here is the 100-year with 2 foot of safe storage, meaning that I just let this levee represent a 2-foot height, and the 2-foot height did contain the 100-year event. The levee is about anywhere from 3 to 5 feet high, depending on where you sample it. And it does have some issues. You can see that it has, let's get rid of these guys. You can see that it has breaks in it and it has all kinds of issues, but it's there. And it's probably, like I said, it's just a spoils pile for this ditch, this irrigation ditch. That's the only purpose for it. So with and without safe storage. And then another issue that I ran into was down here. Let's get down here. I had a levee overtopping event that I was not anticipating. And so I realized, okay, something's wrong. But but it's showing you exactly what I was talking about. See how this water is getting trapped on the other side of the levee? So now that water is no longer moving downstream. And so this levee was overtopped because I sampled my data incorrectly. And I'm going to show you why. Now, if I had stuck with the cross sections that the Army Corps provided and used that as my sampling buffer, I probably wouldn't have had this issue. But instead, I made my own buffers, but I didn't make them wide enough. So let me show you what happened right here. So let's turn these guys off. And first of all, let's do this time map just to see where we are. So this is our 100-year time map. And what we want to see is when does this map start to overtop? So you can see that the water gets down to the system after about, what is that, 9 hours? Looks like about 9 hours. And then it starts to overtop right here. And if you turn on the velocity vectors, you can see exactly where it's crossing that levee. So it overtops because this levee is too short because I used the wrong levee to represent I used the wrong alignment to represent the levee. So let's turn this off and show you what happened and why that happened. So this is the original alignment from the Army Corps, which it looks like they're trying to stay right here. But it also looks like they built an additional reinforced levee right here for this area. So they already knew that maybe this wasn't good enough, is my guess. And I don't know any of the dates or times of when they built all these things. It's been a really long time since I've worked on this project. But let's take a quick look. We can take our profile tool, just dock it right here for the time being. And we can take and draw, whoops, I'm on the wrong one. I apologize. We need to be on this one. Okay. We can take and draw a polyline across here. And then once we start putting our cursor, you can see the little dot moving and you can see that the levee is actually right here. So the alignment from the core was slightly off. But if you had been using, if I, sorry, excuse me, if I had been using the cross sections as my buffer to pull off that elevation, I probably would have picked it up. But instead I was using centroids, point centroids. So let's go back to that point centroid method and let's run it so we can get some of those layers and see if like just increasing our buffer would fix that. Or if we need to apply a different kind of buffer in this area. So let's get this off. I don't want to close this because every time I close it, I have to reload the elevation. So I'm just going to move it off screen. But that means that this guy is probably going to be there and that's kind of annoying. And then we don't need this guy right now. And we can go back to just a cleaner workspace. Okay, so let's take a look at our elevation points. And as you can see, they are um, right along our levee every 500 feet, but they're off from our centroid by this. But look at what happens when I try to edit this line and I pick up the vertices of this line. Let me get on something slightly different because I keep getting on that measure tool. So you can see here that the original core data had point about every 100 feet, I think, or every, I don't know, it looks like about every 100 feet. And when I originally made this data, I did do a bit of alignment in here. But as you can see, where there's lots of vertices, that's where I didn't do any moving of that data. So probably what I need to do is just move that levee to this center line right here. I can either readjust that line right here, or I can maybe increase the radius of my buffer to pick up that variable. So let's take a look at that process. Whoops, that's not right. I want this one. Okay, let me get off of this one real quick. Okay, so this is that Levee Crest editor. So it's going to pick up our levee line and it's going to create a unique point every 500 feet that's going to be centered on that line. You can see here, this is that interval. So you have opportunity to change that. And also this is the buffer radius. So I was using a 30-foot buffer radius. So let's take a quick look at the distance from the center of this to here and see if we can use a different radius to sort that out. Let's go measure line, and then this goes to feet. And let's just do this right here. So that's about 100 feet between those 2 points. So I can either move my line and rerun the processor, or I can maybe set this value to like 100 or 80 or 90 and try it again. Let's try this. Let's try to set it to 90 and let's see what happens. Okay, then we just click run, and what's going to happen is that this is, oh, dang it, what doesn't it like? It doesn't like something. Oh, wait, let me try something really quickly. First of all, I need to make sure that that's not in edit mode, and I might need to clear out these points. Let me clear these points out real quick. Okay, let's try that again. Okay, so it's starting the interpolated points, and then drawing the buffer, and it's still not wide enough. Okay, so let's take these two, remove them, and let's take these guys, select all, edit, delete, selected, and we'll just save that. And then we can just run it again, but let's try like 130. And let's go ahead and clear this. Okay, now that one will probably get it. So now what that's done is this text has, these are the points along the line. These are the buffer around the center of those points. And then that buffer is used to perform zonal statistics on this raster. And hang on one second, the zonal statistics, I wanted to show you that because maybe I can just, the zonal statistics are done using, I think this is a list, and list position 6 is equal to max. So I think I had it wrong to begin with. I was using the min, or I was using a mean, or like it's either a mean or a median. I think the first one it was doing was a median. And so I ran a typical zonal statistics just to see which one of those I was supposed to use. And ChatGPT had me entering the wrong number in here. Okay. So I had to check that because the levee wasn't at all the correct elevation. All right, so now you can see that we have refinished this, but look what happened. This is what it did that's new that you may not have seen last time, is it took and it copied those elevation points back into here with that buffered elevation assigned to them. So let's do a quick, first of all, we're going to turn on our user levies. That will be, well, first of all, let me make sure we're in the right area and we find our overtopping. So let's turn that map back on and let's make sure that we're in the right area. Okay, so we want to be like right around in here. That's perfectly fine. Okay, we can turn that back off. Now we'll turn our user or schema levies back on, and we'll use the ID tool on our levies to select a levee elevation, 4762. Now let's do the same thing, but let's grab the elevation point instead of the levies. So here's our elevation point, 4764, 4766, 4765, and 4764. And let's also take our profile tool and let's get this one like down here. And why is that 4764? Okay, no, that is true. That is going down in elevation. So that's 4765 and that's 4764. So that is indeed true. So this worked properly, and now we have now adjusted our levee up without having to modify the alignment of the levee because it's close enough. I mean, if you wanted to modify it just to be more accurate of your levee center, that would be perfectly fine. But this is close enough for my test. Now the only thing that we have to do is reprocess those levies. So, but before we do that, I do have to tell you that like now, but because I ran this extractor, I now have a points along these guys too. Now, this is my safe storage levee, so I don't necessarily want the point of the levee. I think I prefer having the 2 foot of the levee. So I'd probably delete the points here. So let me go ahead and do that really quickly. Let's do it like this. We'll just select them. Just have to be a little bit careful around that bend so we don't select levee points on the other side of the levee. Now this will be easier. Okay. And we want to, wait, I don't want to get them all, right? Where did that safe, I'm thinking that I shouldn't have done these ones right here. Let me Control Z a handful of times. Okay, let's just get, I think that we just want this one. Okay, that's better. Okay. And then we'll go ahead and save that. Okay, now let me show you what I just did. So this levee right here, we're using a 2 foot safe storage. So it's going to be able to overtop after 2 foot. All right, let's take a quick look at how we set that up. So if you look at the safe storage polylines, they have a null elevation and a 2 foot correction. And if you look at the a levee alignment that came from the core data. They have a null elevation, a null correction, and they have points that represent, and the levee will be interpolated from these points. Between these points, it'll be linearly interpolated from upstream to downstream because that's the way these points work. And then so that's how you could quickly and easily set up levee data. All right, now what we need to do is to replace that, we come here, levee tool, and we uncheck that, and we just click create schema layers from user layers, and that will rebuild our levees, as you can see, processing there. And then this tells you where your redundants are, and this you can just click yes. That will take care of those redundant levees. And then it says done deleting extra levees. So this Python console does a lot of things for you. It's actually nice. You kind of don't realize that it's printing all this stuff for you. Anything that maybe should have gone to the log might come here. Okay, now we go ahead and we just going to do another test run because again, we might need to redo one of those elevations because it might be that the levee is actually below the grid elevation. So if we go to quick run, and we're going to put this to, whoops, sorry, I didn't do that right. Quick run. And then let's put this to levee elevation test. And that should start that test. It's going to if it doesn't start, it'll give us the error where all the problems are. Okay, if it starts, you don't have to fix anything. If it doesn't start, you go to error.check and you look for problematic levees. Now, last week I said that I would kind of more carefully go over some of the other output files, so I'm going to do a little bit of that right now. Now, output files are for levees I mean, if you don't have if you're not running any failure, they're pretty simple. They just, indicate whether you have overflow or whatever. So let's just sort this by name, and then we'll just hit the L key to take us to anything that starts with L, levee. So we have levee data.dat, levee deficit.out, levee overtop, low levee crest elevation. So these are our kind of like generic output files. And then if you have failure data, you'll also have some HDF5 and some different options that tell you like, when is your levee failing? How much is it failing? What is the extent of the failure? Things like that. So let's go ahead and just open these with Notepad++. Let me see. I'm going to do this. I'm going to do Control-Shift-W, and I'll do that again. Control-Shift-W just closes everything. So this gives you the idea of which levees are overtopping and the discharge that crossed them. I think if it's a negative, I think that means it's flowing. I'm not sure what the negative means, but one of them is probably flow direction. I can't really remember what it means, but it's probably something to do with flow direction. And then what is this? It says discharge in time. Okay, so this is the time, this is the discharge, and this is the grid element. So again, remember, if you are in Flow 2D and you are looking for a specific grid element, you just come to I got to turn on, I got to hit the ID tool to activate that. Yeah, I just use this tool to turn this grid info on. You paste that there, and it'll take you right to your bad levee. Let me run this again really quickly. Sorry, I think I want to set this to the 100 year, and we'll click schematize, and let's just do this quick run, and then we'll put it in new folder. We'll put this in levee, let's see, 100 year, 2-foot safe storage, corrected. And that will just run that while we're looking at these other output files. I just want to get that running while we're looking at the output files. It's super, super fast, so we won't have to wait for it. Okay, so we have our overtopping information. So that's a really quick way to find levee overtopping if you have like 200 miles of river to check. Levee def All right, levee deficit dot out here, and here is the levels. Okay, so 0 is greater than 3 feet, 1 is 2 to 3 feet. Now that's freeboard. That's the amount of freeboard left. 3 is less than a foot of freeboard, and 4 is overtopped. Okay. And so you'll see that it's for every single grid element, but of course, only a handful of our grid elements compared to the whole model have data. So so you can see that they'll have a handful of them here. Okay. We also have levee.dat, which I think we maybe covered last week. The levee.dat is organized sort of in the worst possible manner. So it's not really easy to build this file with anything other than the Flow2D tools. So it's better to use QGIS to build your levees. And then levee crest elevation.out. This tells you when you have like a levee that might be underground. So this will be something that you want to look at. And again, we know that because we know those levees were bad because we were able to go into that and rebuild those with the actual appropriate levee. So we know that there were bad ones in there. Okay, so this is the levee crest elevation and the ground elevation. And what we don't want to see is negative numbers. All right, now let's see if that run finished, which I think it did. And we can map it and see if we can pull and see if we have that same overtopping issue in that area or if we fixed it. Right, so let me do ID and just get off of those guys so we don't have to see that buffer. And then we'll just import that. Again, we just want that max depth. So we'll use raster and then we'll do 100-year safe storage and then corrected. And then we'll grab that from here. Run it. And looks like we are still getting some overtopping, a little bit of overtopping. Let's see, what do we got here? Not like before, but it's definitely there. So if you're still getting overtopping and you know you've corrected it, your next bet would be check isolated events or are you absolutely certain you're running the 100-year hydrograph? Because honestly, I can't really say that I'm 100% certain that I'm doing that because this hydrograph seems a little fat to me. So it might have a little bit too much volume in it. So those are ideas for behind levees. And that's basically all I wanted to get to today, to show you these methods are valid and good and easy to put into place. So if you're interested in this script, again, we will be publishing this here to this guy right here. After the day is done, we'll be publishing the video and the script is already there. And then I'm also going to put the project in here too. So notes on the project, not important, just so you know. The project is done with QGIS 3.40 and it's done with the Flow2D plugin is also new. So let's go plugin, manage, install. This is the plugin that we are using that we're testing and everything right now. So version 2, and these are all of the different things that we've been doing to it. We're going to be releasing this probably in December, but if you want to get it right now, I'm going to put it in that folder and I'll just put it in that folder with the rest of this code so that you can open this project if you want to look at some of these techniques. Okay, I'm going to stop the recording now. Maybe, if I can find it.